Okay, in this video, we're going to practice drawing, especially these geometry things. In geometry, you're often given problems that are word problems, and you're going to have to draw the picture so that you can, see what's happening and be able to figure things out. So we're going to go through this, well, not that, and see if we can be helpful in drawing these things. Okay, so the instructions are to draw and write all the relationships that exist. So this one says draw angle COW. So we can do that. Remember, an angle is made up of two rays, and we name them by having this be the vertex. So O is in the middle, and then C and W can go on either side. It really doesn't matter which way you draw it. Okay, the C can be here, and the OW can be there, or they can be switched. The one thing is true, the O has to be in the middle. Okay, so this is angle COW, and there's really nothing else to do here at all. So now moving over to the right, we have ray RI. So ray RI starts at the letter R and goes towards I, is the bisector of angle ARM. So the first thing we have to do is draw angle ARM. Whoa, that's not exactly straight, but good enough. Okay, ARM means it has a point A, a vertex of R, and another point of M. Now, ray RI, so that means it starts at I and is the bisector. So it's right in the middle, goes right down the middle of this. So let's see if we can draw this as middle as we possibly can. Right down the middle. About. Okay, so out here there is some point I. Okay, so a bisector means it makes this measure the exact same as that measure. Okay, so these angle measures are equal, which means that angle A to R to I is congruent to, right? The angles are congruent. ARI is congruent to IRM. Okay, these angles are congruent. Okay? So what we could also say then, therefore, since the angles are congruent, if these had degrees, right, if this was maybe a 40-degree angle and this is a 40-degree angle because maybe ARM was 80 degrees, I'm just making these up, that means the measure of angle ARI, the 40 degrees, is equal to the measure of angle IRM. Okay, a little bit of a differentiation between measures, right, their degrees being equal, but the angles being congruent. Okay, so those are the relationships here. The measures are equal, the degrees are equal, the angles are congruent. Okay, pretty nice drawing. WHA and AHT form a linear pair. So linear pair. Pair means two angles that form a line. So we start off by drawing ourselves a straight line. Okay, and off of that line, we draw another line or a ray that makes two angles, right? There's one angle here that happens to be obtuse looking, and this one is an acute looking angle. I have no idea what they actually are. But WHA and AHT, so that means that the vertex here, they share this, is both H. Okay, so here's WH, and then we'll put A up here. Here's angle WHA, and then the other one is AHT. So there can only be one letter, right, one ray that has this name within the picture, which is why these two are connected by this adjacent angle or shared ray, the common ray here. And what we know is that the measure of WHA, right, this angle, plus the measure of angle AHT. So if I add these two angles together, this angle here and that angle there, they should add up to 180 degrees because that's what a linear pair, that's what a straight angle is. Okay, it adds up to 180. So this side of the angle plus that side of the angle adds up to 180. That's the relationship in a linear pair. Two angles that add up to 180. Okay, line. Lines are straight. This is 180 degrees, flat open. Alrighty, let's move over to here. OT, remember this is ray OT. So that somewhere it starts at O and goes in the direction called T is the bisector of angle WOR. So first we have to draw angle WOR. So here is angle WOR. O is at the vertex because it's in the middle right there. So here's W, O, and R. So OT starts at O and goes right down the middle of this angle. It's the bisector. So we're going to put T out here. And that means that this angle is the same measure as that angle. Okay, so we have angle WOT is congruent to angle TOR. Okay, it gets bisected, their measures are equal, so the angles are congruent. So what's next is now we have, A is in the interior of angle WOT. That means it's between in here somewhere, right? This is interior to the angle. So let's put it, I don't know, wherever you want to put it. I'm putting mine there. And it says point E is interior of TOR. So here's TOR's interior, right? It's between the two rays there. Let's put it right here just for fun. Okay, so there's nothing else other than having two congruent angles. I guess we could use the angle addition postulate and say that the measure of angle WOT plus the measure of angle TOR, okay, these two smaller angles add up to be the measure of the larger angle that we began with, right? This angle plus this angle equals WOR. Okay, that's the angle addition postulate that says you can add up smaller angles to equal the larger one. And it's kind of handy sometimes to do that. Okay, let's just do a couple of other ones here. Angle CAR is 3x plus 12, and RAM is 2x plus 8, and they are complementary. So complementary means adding up to 90 degrees. Okay, so if we were to draw this, so we're going to make sure to have a 90-degree angle, because that's what it means to be complementary. Okay, so here we draw something in the middle. CAR is 3x plus 12. And then in here, RAM is 2x plus 8. So that means we add up these two angles, 3x plus 12 and 2x plus 8, and that needs to equal 90. Okay, that's what a complementary angle does, 90. So we solve this together. 3x and 2x is 5x equals plus 20. 12 and 8 is 20. So 5x equals 70. So x is 14. So if x is 14, what are the measures of the angles? So now we have to go back in and do a little bit of solving here, or multiplying. 2 times 14 is 28. 28 plus 8 is 36 degrees. And then if this one is 90, 3 times 14 is 52. 52, and this is, 42, and that is 54 degrees. So CAR, the measure of CAR is 54, and the measure of RAM is 36. Okay, so complementary angles don't sit around all day telling each other how nice they look. They actually add up to 90 degrees. All right, so here's another one. Angle WHO and OHM form a linear pair. Okay, I can do that. Here's my straight line, and here's my second ray, WHO. So here's W and H and O, and then O and H and M. Linear pair, check. G is on ray HW, so ray HW starts here and goes towards W. Okay, G is on HW but not on WH, which means, okay, so there's HW. WH starts at W, let me change colors, starts at W and goes through H. So that must mean that point G is over here to the left of W. Okay, it can't be in between. If it's in between, then that means it's on both rays. If it's over here, then it's only on ray WH. Okay, so that means that G is to the left of W. That's what this information is telling you, to the left of W. Okay, these ones are especially hard because they're opposite rays. Well, not exactly opposite rays, but they go in opposite directions. Okay, so that's good for now. I'll make another video for the rest of it. But learning to read the geometry and then writing down, drawing pictures, and writing relationships is what this is all about.